you think there might be one. And Tiger slash who did that, even though we may find out that it's not really there. It's important to let us worry, tell it about it. So I really appreciate him going that extra mile. Okay, guys, come in, close the door. The agenda's tight. Love to have you here. Just come in. We'll start. I think I'm at one.
You're ready.
Yep. Okay, the agenda's really tight. Everybody look at Caton and say, thank you, Caton, because he got us 3 sessions, but we've managed to fill them to the brim, okay? And be very tight on this schedule. This schedule, as we walk through with, before we started, I went to the note well. I went to the importance of disclosing IPR. If you're coming in late, please read the note well in the slides. If you are participating, you must disclose IPR. If you're discussing with someone, you must disclose IPR. You must treat everyone else courteously. That's the basic, read the note well. Okay, our charter is approved. It was a really good charter and discussion. We have started grouping drafts and running drafts through the adoption and the pre-adoption review process, the adoption, the working group, and the working group last call by 4 groups: CORE, SR, SRT, BGPLS, and FSV2. I guess that's actually 5 groups. Today we're going mostly CORE presentations. Friday first session is SR, SRTE, and BGPLS. If you don't know what those things mean, SR means segment routing, SRTE means segment routing for traffic engineering, and BGPLS you should know from the document. Okay, the second session is on FlowSpec V2. That was what we set in our agenda, but we had to do a little bit of arranging for people who asked us to squeeze them in one place. The full status is at is on the GitHub. We have not gone to a wiki status. We've gone to GitHub, which the chairs use daily to update status. So if you want to see it, there's the URL. You can review it. Okay, I'm going to go through a very brief status. There's more on the web. We go in the web through working group last call, adoption, early allocation, pending stuff. On the wiki, there are Shepherd reports. Okay, who's at the RFC editor? We added next draft IETF, IDR, NHC. We added VPN, ORF, and RFC 4360 BIS. I'm not reading all the names. Does that distract anyone, the fact I don't read IETF, IDR? Okay. So at the ISG is draft IETF, IDR, BGPLS, inter-AS topology extension, the draft from SR policy on NRP, and the draft IETF, BGPLS, SR EPE over L2 VPN, and we have 2 in active AD review. Caton is doing a really good job of keeping up or handing it off to Gunter. Gunter is also very effective in his reviews. Now, I am behind on Shepherd's review. Expect reviews in all the non-core areas during the week. So if your draft is a working group draft or a pending draft, I will send you a Shepherd review that says, here's how you get to the next step. We are trying to run things as quickly as possible. Please pay attention to the list or to my email directly. Okay, past working group call. BGP model. Jeff has a discussion. I won't go through that. SD-WAN, there's just a few last tweaks on the Shepherd report, but the document's done. draft ITF IDR TS flow spec, SR policy. The author sent in the revision just before the meeting, so the Shepherd, Kate will go on. And then I have one, you'll find a number of these drafts. I've got to go and see where Spring's current status is. And Alvaro and Joel and who's the third chair, guys? Bruno, right? Spring? Yes? Yeah, good. My brain didn't stop. That I'm reviewing that for the last CT draft. The BGP DMZ was one that was in the IPR. If you have an empty seat next to you, raise your hand. Okay, there are still plenty of places. This is going to get tight, folks, so grab a seat soon. So good news is that Chahu went back and helped his lawyers find the right stuff. There's no IPR on the DMZ, I think, on that one as well. So that's good news. I hope the best chairs are here. And derived community is a discussion. Should I do that at the end or so we have plenty of time?
We can save it.
Now?
Save it for later.
We'll do this. I sent out a message to the draft ITF IDR derived community. We're going to do this last, unless you wanted to do it now.
No, it was on the IPR thing. I would appreciate if Shahu sends an email on the IDR and best list confirming that there is no IPR.
That would be super.
Please,
Good idea.
Please do that.
Did we miss anything else? Okay. Caitlin's been very helpful to us. Okay. Link local. Okay, guys. If you're in the queue for draft, we really raise your hand if you have an empty seat, folks. Next to you. There's a couple there. There's a couple there. Please. And there's one up here at front. I really do not bite. The link local capabilities could still use a framework. Did you have something?
Sorry. I just sorry to interrupt because this is IPR and it's important. Can you clarify whether you have it on the best DMZ draft as well?
No. Yes, no, not on
Can
the.
you do that on that email as well? Thank you.
Yes. So the draft IDR link local capability, it was finished a month ago, but we still could use some more comments. If you're interested in this, please comment because we get into these stuck modes. Draft Utaro was extending the adoption because I don't have an IPR statement from Bin Wen. Unless I get IPR statements, I can't close a working group adoption. Latowski RTC Inter AC is a very small draft. It's easy to read. Do us a favor, take a look at it. We think it's something that's out there and we should standardize, but it needs more. The same is Varun BGP best path selection, next top best top selection, and Bruno's draft on LRI handling. They're going to be discussed today. Please make comments. There were technically closing today, but we'll take comments all week. Okay. Core pending. Next hop nodes. RDC hierarchical right RR, which G is going to show some additional comments on that, and draft RTC no RT. And we deprecated a whole bunch of drafts. I'm running a little bit behind, guys. There are adoptions in process. We adopted one SR draft, and I ran into a procedural error where I realized that we adopted draft Ali BGP LS SR SL op distribution. Love these names. We adopted it as a unique draft and then merged it with the other one, but I hadn't called an adoption for Lin BGPLS admin policy. If you get a chance, please comment. And we will start this week on an SR. Does it sound like we're doing a lot of work? I think we're doing okay. And then there are upcoming assignments. Now, this is important for everyone. I'm saying it now, even though we'll cover this in detail on the Friday sessions. Look, to help everybody get their code points effectively, even though the BGPLS is first come, first serve. And I'm trying to work it through the working group to make sure we don't have any problems, and then working with Diana to track down your code points. So if you got a code point you want for your BGPLS draft, let me know and I'll try to help you. The same is true of SR drafts. Those I have to review and send forward. But we've been able to close last ITF's gap. We had 4 that were sitting out there that had sort of pseudo squatting on it. We've closed those. If you're looking for an SR draft code point and you've been a working group draft for a while, send me a note so I can try to help you go through that quickly. I've already gone through the rest, guys. I think I'm done.
Okay.
Did I miss anything you know of?
Nope. I will take the slides back.
Okay. Then we'll.
And I'm next for the next 2. If you can drive here.
Oh. Questions?
Yep.
If
quick,
so,
we're out
put
of
it in the
time.
chat.
Okay, I will need you to swap the slides over for the bib in a second. Hi, I'm Jeff, and I'm going to try to recover some of our time for the next 2 slides. So this will go very quick. So I'm here for this first set of things to present on 2 pieces. The BFD strict mode feature that I'm doing with Mirsa, AC, and Albert Fu. And overlapping that is work that we've had to do about exposing the finite state machine code points out to INF for maintenance. So very simple statement about what the problem is. BFD and RFC 5880 says we do BFD. We have multi and single hop BFD formats, and we have a generic document 5882 that says when you take things down, we want the session to go down with it. It's less good about saying what to do when you bring the session up. And the side effect is we have interop problems across the vendors based on where they start BFD versus the BGP state machine. This has caused wedged sessions, so it's a real problem. So why does BGP care about up? Well, we depend on exactly where we start things, and very specifically, some implementations were not even starting BGP until BFD went up, and some started BGP first and then waited for BFD to go up. This is a recipe for deadlocks. It's not a happy thing. We tend to see this in the field when a hold down mode is configured, when we want to actually make sure BFD is up for a stable period of time before you allow BGP to come up. Very simple problem description. Deadlocks, what do you do about that? Well, the answer is pick one side, and once we actually do that, we want to make sure that we both agree what we do. We do this through a capability. Easy? Yeah. Well, it's like the actual answer for this on the wire is just simply wait for BFD to come up before you send your keep alive to make BGP say I'm established. The problem is if you do anything in the BGP finite state machine, thank you, Alex Zinnin, so many years ago, keeps on being pain that you keep on giving us. The amount of text that you need to do to say this one sentence is gigantic. John is going through similar fun for 4271 bis. I'm sure you'll tell us about that later. This means that we need new events. We had a send hold timer RFC that went out that also needed new events. What this means is how do you actually track this stuff in the state machine? Our choice was to go with substates. And as part of this, we also had to figure out how do we actually latch this into the state machine. The first round, when we did the expanded state machine work, we thought this was open sent. We did an audit as part of the work that we did for BGP over Quick, where we spent a huge amount of work with Ying Zhen, trying to figure out what the FISM looked like. We figured out that this was really open confirm, did a huge amount of document update that changed 0 on the wire. This was sort of a point about how bad the FISM actually is in many respects. Exactly how we maintain the FISM is going to be a longer discussion. And past that point, we still have a reason to document these things and take these code points because we're going to expose them eventually through things like Yang modules. So we have to put together a registry for it. Very boring. That said, both pieces of work have completed. We are now ready to actually take both the documents to last call. We've made the request on the list. This is your chance to actually pay attention and ask questions. There are at least 3 implementations, so we're good to go. Let's get things moving. quick questions before we move off to the next presentation? Excellent. Carrie, could you switch me over? You have to unshare the clicker.
Where is it? I have to do it. One second.
That's here. And then get that to share again. And then confirm. And then you get to click the share again. And then save this. So one of our bits of joys as a chair is they added a bot to control the clicker here, but it also means that you get to argue with the machine before you switch things. So a very brief update on the BGP model, work that we're doing with the Hesh, and basically all the chairs up front. This makes review of the model a little bit interesting. So document history, we promise there are going to be no Yang trees during this presentation. You've had enough of them. Previously, we last called this in 2024, but we left it waiting for implementation because our tradition is 2 interoperable implementations. Since then, we've had pressure to ship the document anyway. So this has been a conversation not only with the AD, but also the Broadband Forum, who sent a formal liaison statement saying, we would like to use this IETF stuff. Fun detail in other presentations, like the NMOP presentation earlier this week, we have other people making use of the model for things like BGP streaming telemetry. So success, people are using the stuff. So we're moving the stuff forward. What does that actually mean? Well, we had to do the last tiny bits of cleanup as part of this. The most impactful thing, thanks to the discussion with Maria, is we have implementations that wanted to actually key on things other than the IP address of the neighbor, and we had to add a little bit of flexibility for that. I got some help modeling that sort of thing. A lot of the rest of the work is 2 years was enough for us to actually have to make changes in how Yang is actually done in IETF. Semantic versioning is now a thing. People that are familiar with OpenConfig and other projects, you've been there for a while, IETF is now actually doing it. We did a little bit of rearrangement and cleanup, and as part of these efforts, we had cross-correlation versus the OpenConfig model that provides parallel functionality in a different organization. This gave us a small number of changes. We did ask dynamic peers. We created a BNF format for the ASPath regular expression language, added statistics. And we also got some feedback as part of a updated Yang Doctors review from Andy Bierman. Thanks, Andy. The biggest thing that actually changed in terms of churn in the model was caused by updating the IANA considerations. This is another piece of procedure that has been updated since 2024. Things that are maintained by IANA require clear instructions to do so. This caused us to move some stuff around. Things moved. We didn't actually change the contents, but this made a lot of churn in the document itself. Biggest thing that I actually like us do is clean up the extended community encodings. We found a better format to allow us to do this for maintenance purposes. And one of the nice presentations we have queued up later is Miriam talking about a similar problem about how do we canonically model these sorts of things, both in a independent reason and a human readable one. So our steps right here. We're going to have a bit of a review on this, addressing the last bit of the Yang Doctor stuff. We will be communicating with IANA about the last pieces of the procedures, and then hopefully send this to the ISG. I have a quick question for Xuan.
Yeah, Xuan Song from ZT. Have the BBF liaison officer hat. Yeah. Thank you very much for the presentation of the draft. It has the draft status update. Actually, BBF has expressed they use this draft as reference for their work WT for 77 issue 2, and their work is progressing to the completion, but they would not be able to publish it unless or until IETF published the BGP data model draft. So I think BBF certainly support to progress this draft to IESG to publication.
Okay,
thank
and as part of IETF processes, and we have talked about this amongst ourselves, we'd appreciate if the BBF and other organizations that have interest participate in the last call and review. That way they can make sure that we don't ship something that they can't use.
Yes, I can, and actually we can also send liaison to BBF. Tell them how to do that.
Exactly.
Okay.
Thank you very much. And hopefully I've recovered a few minutes.
Just this draft, the chairs have been carrying it or maintaining it and improving it for a long time. The fourth author is the current management AD. This probably may be the largest ever Yang model
240
document of the IETF. And I've been asked to call consensus on it for that reason. I would really appreciate people voicing their opinions on the mailing list. It doesn't need to be perfect. There is parallel work with Yang versioning and all of that happening, which hopefully makes some of these things easier to maintain, fix, improve. That's this thing. But please, I need some responses on the list. Thank you.
Thank you, Ketan. Shahu?
You want the other one first?
Oh, you wanted the other?
Yes.
Okay, let me switch it first.
Hello, everyone. I'm Xiaohu from China Mobile Cloud. Let's talk about how to use FAIR in multi-plan scale-out networks. Currently, more and more large-scale AI training cluster are considered to use multi-plan scale networks in order to reduce the usage of switches and optical links. In such scenario, there are no interplan links within the fabric. So the RDMA NIC need to detect reachability and even the path bandwidth of each plan in order to perform ECMP or even weighted ECMP across those plans. The FAIR in Sun proposed to extend the BGP FAIR protocol from switches to GPUs. And for multi-plan scale-up networks, the same technology could be applied to the multi-plan scale-up networks. There are two major differences. One is the protocol extended from switches to the RNICs. The other is this multi-plan scale-up networks will require much larger routing tables than the multi-plan scale-up networks. Assume there are scale networks consisting of 100 key GPUs and 4 plans. It will require about 100 key host route to be propagated across each plan. The RNIC should install more than 400 key host route. That is not possible from the perspective of RNIC. In addition, it's not optimal for switches to install those host routes. So we need some routing table reduction mechanism. There are two options. One to use route aggregation with unreachability notification. The other is to leverage the prefix or F mechanism. In the former approach, route will be the host routes would be aggregated when advertising them from leaf switches to spy switches. However, if there are no other mechanism for unreachability advertisement enabled, there will be a black holing issue. So we offer two options. One is to use the normal route advertisement with the pass bandwidth attended, and the value is set to 0. The other approach is to reduce the UPA mechanisms defined in those two drafts. Upon receiving reachability advertisement, UNIC need to update its forwarding table as follows. First, it's locate the best match subnet route covering the unreachability host route. Then from those next hops of the aggregated route, remove the next hop of the affected plan. Then the UNIC will install a specific host route with the remaining next hop of the aggregate route. Another approach is very straightforward. It's just to leverage the ORF mechanism. In addition, since there are no need for switches to install all host route in its FIB, we can use some FIB suppression trick. For example, when receiving host route from UNIX, leaf switches could tag FIB suppressed extended community attribute to indicate those host route don't need to be FIB installed. Oh, that's all. Any comments or suggestions?
Hey, Krishna Swami, Cisco Systems. Can you go back to the previous slide? Yeah, what happens if we advertise only a default route is being used on the NIC?
You mean the NIC only use default route? In our approach, I prefer to advertise aggregated route instead of a default route to UNIX.
Yeah, I mean, on one angle, you're trying to reduce the host routes. Why don't even reduce the subnet routes too? Because NIC has only a certain way of going out, only to the leaf, right? Why do you even need an aggregated route? I mean, think about it.
Okay.
Right. So that's something to consider.
Yeah.
And I'm also a contributor to the UPA draft.
Okay.
Right. So there are newer versions coming with a lot more things getting handled as a part of UPA, and we can discuss and see that how this is overlapping. The UPA work is getting overlapped.
Yeah, I have considered this, the pros and cons of those two options. In my opinion, the use of a pass bandwidth value setting to 0 is more helpful in special use case. For example, if some length of SerDes are given transceiver doesn't work, but the remaining SerDes could still be used. In that case, the route advertisement with pass bandwidth could still advertise the the remaining bandwidth. In that case, the pros can advertise three status: reachability, unreachability, and partial reachability.
Okay.
That's the main pros.
Sure,
You can say next session time.
Okay. Oh, okay.
Thanks.
Oh,
Jeff, did you want to keep it very brief?
Just into NVIDIA, just a quick answer. You can't have default because network are rail optimized. You need to exit rail that goes to destination rail. Otherwise, SOL12 will break down.
And I thought you were going to ask to be an author. He knows what I think about the solution.
thank you.
Hey, I'll be real quick. K. Patel Arcus. I think that's what I was going to comment what Jeff said. You can't do this with default route because there's an east-west traffic going on. So you need to have subnets.
Okay, I just give a quick update of the changes this draft. We add a new cursor since the last version. And we also add some clarifications about the two scenario. One is the use of multiple BGP sessions between switch pair. Another is packet forwarding over tunnels. Okay, for the first scenario, when multiple BGP sessions are used between a switch pairing, the path bandwidth calculation must be performed on the node granularity rather than the session granularity. When the packet are forwarded over tunnels, we can attach the path bandwidth value to the route of the loopback addresses, which use that tunnel endpoint. So in this case, the logic of the fare could still be valid. Currently, we have more implementations, including multiple vendors and multiple chips. I think this draft is ready for working core since I have declared there are no IPR. Okay, thank you.
So thank you for clearing up the IPR issue. That makes things easier. A thing that you will also have to do before we will start a adoption when we're ready to is there is a 5-author limit on the drafts. To go.
Okay, I see.
So the fact that you can fit so many authors onto one page is impressive.
Okay. Just remain 5 or 6. Okay.
So I think the fair base proposal has been well understood. So we'll see what we can do about getting into the adoption queue. For the other document, more discussion obviously would be good.
Yes. Thank you.
Okay. Thank you, Sean. Our next presentation will be the Orff-Yang model.
Hi everyone, I'm Fan Zhang from China Telecom, and I'm presenting a new draft young data model for BGP outbound route filtering and for the article authors. And first is the overview, and this draft was triggered by the review of the VPN perfect auth draft, and which said it needs for a young model. And during the design, we find the current IETF BGP and its related young module do not cover all functionalities. So we extend the existing model to support the auth. And this document defines the young data models for the configuration and management for the BGP auths, including like the generic outbound route filtering capability defined in 5291, and the address prefix ORF defined in 5292, and coloring prefix ORFs defined in 7543, and the VPN prefix ORF we've mentioned in the as the draft we mentioned, and we've defined in like two YANG modules in this document. One is the IETF BGP ORF YANG. The other one is the IETF BGP VPN prefix ORF YANG. So first is the module or IETF BGP ORF. It's basically contains of like it contains like three main components. First is the generic of capability. We defined a grouping for the of capability advertisement with a list that with the supported of types and whether it is the speaker support the send or receive or both in for each ORF types. And the second one is the address prefix ORF. We defined a grouping for address prefix of entries, and we're using for the configuration of the entries advertised by the local speaker, and also the operational state for the entries that receive from the peers. And this part was augmented to the IETF BGP model and is applicable to the IPv4 unicast, IPv6 unicast, both neighbors and peer groups. The third part of it is the CPORF, and we defined defining separate groupings for the CPORF entry list, like for VPN v4, VPN v6, and EVPN, since they were different in their constraints about the route types and host address, and also they were like you were used to for the configuration of the entries and the receive entries that generated by the speaker and received from the peers, like the former one, and also augments to the IETF BGP model, and it's applicable to the L3 VPN, IPv6 v4 unicast, L3 VPN, IPv6 unicast, and the L2 VPN, EVPN neighbors and peer groups. So the second module is the IETF BGP VPN prefix ORF, and we defined a grouping for the quarter policy, which contains its the quarters like with the RDs, source B, quarter overload VPN routes process method, and the and we reuse it to augment on the different address families for their to define their to configure their quotas. And also we defining a groupings for grouping for the VPN prefix of entry and for the operational states of the generated VPN entries and send it by the speakers and also the received from peers, and it's applicable to the address family that's listing there here. And yeah, that's it. Any comments?
Okay, well, we're waiting for comments in the queue. Channeling Keaton from the chat, he's requesting that the authors for the ORF Yang module please comment on the BGP Yang module last call.
It's in the chat.
In the chat, yes.
Oh,
My second piece of comment is that thank you for taking on the work to document and build Yang for all ORF, not just one. One of the discussions that we have not started yet, which will probably be IDR chairs, Keaton, and other routing working groups, is now that the base PGP model is done as we have people augmenting it like yourselves, we will have to have a review process for how things integrate. So, we will supply feedback.
Thank you.
Any other questions? Okay, thank you for the presentation. Okay, David, you don't need to share your screen. The slides are up. We'll just pass you the slide control in a second. Would you please test your audio while we're doing that?
Hi, everyone.
We can hear you loud and clear. You should have slide control. Go ahead, please.
Okay. Thank you. Good day, everyone. My name is David Smith, and I'm a co-author of a new draft entitled BGP Route Reflector Deployment Considerations. And in this slot, I'm going to walk through the motivations, topics, and objectives of this new draft. To begin, we intend for this draft to be an informational draft only, because it's not proposing any new protocol changes or extensions. The primary purpose of the draft is first to examine the common route reflector deployment models and the distinct trade-offs of each. And secondly, provide best practice recommendations to help operators maximize the performance, scale, and availability of route reflector infrastructure. Now, we believe there's a need for such a draft because improper deployment of route reflector infrastructure could introduce risks to overall network performance. And just to give the working group a sense of, the types of things that could go wrong if route reflectors are not deployed correctly, we've provided a list here. So, for example, if the limits of a route reflector hardware platform are exceeded, it can put an entire cluster at risk. If excessive route reflector redundancy is deployed, then clients are forced to process more IBGP sessions, more updates, and more paths, which could be detrimental to clients. Obviously, larger cluster sizes increase the blast radius. And if multiple address families are coupled together, either on a single session or on a single route reflector, then a failure within a single address family can potentially affect other address families. A slow client, for example, within a cluster or within an update group could degrade the performance of the whole cluster or update group. If a route reflector is hiding paths, then that could result in suboptimal traffic forwarding. And of course, poor TCP transport performance could degrade both BGP performance as well as overall network performance. And session resets introduced by session prefix limits, those could affect network availability. And then lastly, packet loss or BGP packet drops due to aggressive control plane policing could also affect network availability and overall network performance. Okay, so now these are just a subset of example issues. There are others which we cover in the draft, but for all of these reasons, we think there's significant value in such a draft. Okay, and that it's important to document these issues because to date, we don't believe these are all well understood or well documented. Okay. Okay. So Here's the list of topics that are currently included in version 0 of the draft. There are other topics which we intend to add to future versions of the draft. And again, we think these are important and interesting topics that should be documented. Okay. Now, we're obviously not going to be able to go through, all of these topics in this slot, but we will go through several just to give the working group a sense of the draft. Okay. So, for example, in large-scale BGP networks, there are 3 common route reflector deployment models, specifically multi-cluster route reflector deployment models. The first being a full mesh amongst clusters, right? This is, a very simple design that scales very well and provides efficient path delivery across the topology. The only limiting factors are the full mesh between clusters, and when adding a new cluster to the topology, it requires reconfiguration of all the existing route reflectors. Okay. The second multi-cluster design option involves multiple tiers of route reflectors. Right. So at the lowest level, the border routers, they serve or act as clients of, say, tier 2 route reflectors, as was the case in the previous full mesh design. But instead of the tier 2 route reflectors having a full mesh, they act as clients to tier 1 route reflectors. And the tier 1 route reflectors have a full mesh amongst themselves. Right? So this multi-tier design enables massive scaling because it avoids the full mesh between the tier 2 route reflectors. However, because it introduces this additional layer of route reflection, it could degrade BGP convergence, right? And then, of course, because tier 1 clusters, and secondly, tier 1 clusters could have a very large blast radius. Okay. The third design option, multi-cluster design option, involves multiple planes, right? So in this slide, we illustrate a dual plane design with red and blue planes. The clients or border routers peer with both planes, peer with the route reflectors of each plane, and then the route reflectors can either use the full mesh amongst themselves, as described in the first design option, or a multi-tier design as described in the second, right? So a multi-plane design provides 2 benefits or use cases above and beyond the previous 2 designs. One is increased redundancy, and second is horizontal scaling of the BGP control plane. Okay. Another topic we review in the draft is path selection. And this is because by default, route reflectors compute and advertise a single best path only. And they also use their own IGP metric to the IBGP next hop during its best path selection. And so these default behaviors could result in path hiding, which could lead to suboptimal traffic forwarding. Okay. Now, there are a number of techniques to mitigate this, as listed here. And so, but each of these techniques have distinct trade-offs. Okay? And we review those trade-offs in the draft. As I mentioned earlier, there are some additional topics that we plan to include in future versions of the draft. Multi-hop BFD, BGP graceful restart are 2 examples. Multi-hop BFD is a good example because we've We know people who are strong multi-hop BFD proponents, right? Running multi-hop BFD between border routers and the route reflectors, for example. And we also know people who are strong opponents of multi-hop BFD. So regardless, if the working group can't gain consensus on this specific topic, then at a minimum, we think the pros and cons of this option, the use of multi-hop BFD, should be documented so that operators can then decide for themselves. Operational topics are outside the scope of the draft, okay? And for that reason, we are considering, if the working group decides to adopt the draft, to renaming the draft from route reflector deployment considerations to route reflector design considerations. Okay. In terms of next steps, the authors welcome feedback from the working group and collaboration. And secondly, we request adoption of this draft as an informational draft, because again, we believe it would provide significant value to the operator community.
Yeah. K. Patel Arcus, this is good work. I think if you're going to do this, and if working group is going to take this work, then you should look at all the old RR documents that people had written. What happens, maybe refer them at least minimally or talk about them. One is about hot potato routing and route reflectors. Second is full mesh versus just the route reflector, meaning clients full mesh together versus non-full mesh. What happens? Typically, these route reflectors, Dave, are deployed with IGPs. So how do you set up IGPs so that you only attract the traffic that you want, but it's not used for a transit forwarding? And last but not the least, think about what can you do with GR, because these things carry with full internet table. They go down, they come up. Same table has been seen again. How do you optimize that? In short, make it more holistic.
Okay, agreed. Thank you for the feedback.
Hi, John Scudder. Thanks for the presentation. If I wasn't persuaded before that it's a reasonable thing to write down operational considerations for route reflection, I am now. My question is, why are we placing this in IDR and not in GROW, since we have 3 sessions that are completely packed in IDR, and GROW is less overtaxed, and this seems more in charter for GROW than it does for IDR. Have you considered that and decided not to, or you just didn't think about it?
Honestly, we didn't think about that to date, but that's a valid point. Thank you.
Thanks. You might want to take it up with the chair's co-authors, ADs. Thank you.
Yeah, and Jeff, so John's beat me to the point I was going to make for you. So GROW has this within charter within many respects, although as you're sort of pointing out, this is a little bit hybrid in terms of what its goals are. I did paste into chat that GROW does already have a operational security considerations document that there's, let's call it about a 15% overlap with the stuff inside of your own document. So minimally, we want to make sure those 2 pieces, like transport security, advice, is made harmonious between the 2. I think the answer that we're looking for where we adopt, we'll have to have a conversation with our AD and see what they think. And the one thing that's to our benefit is the rechartering process did give us some latitude towards informational documents of this type. So we'll chat amongst ourselves, and please keep working on this and take it to the list for further discussion.
Okay, thank you.
And quick comment to what John and Jeff said. Looks like skimming through the draft, there may not be guidance for implementers. Should there be a guidance for implementers, then we will take a look at it and see whether it belongs here or in GROW.
Okay. Well, thanks for the presentation, David. We're going to move on to John. Now talking about 4271 biz. I'd gotten slightly out of order earlier. Take the clicker, and you have control.
Thanks. Hi, everybody. It's been a while since we talked about this last. Sorry it took so long. Hopefully things will proceed faster from here on out. So a little bit before this meeting, I got around to publishing draft 01. I'm not going to try to come up with a cute subtitle for every version of the draft, but I think this was the low-hanging fruit edition, where I think just about everything that I merged in is stuff that at least I thought was relatively non-controversial. There were a few things that people came back to me later and said, hey, can we talk about this in the group? And those we reopened the issues, and they're covered in the slides to come. Other than that, I'm not going to talk about what's in 01. Please do go and review it if you have the time, because otherwise, when we come to working group last call, you are going to have a very large review. So now that the low-hanging fruit has been plucked, most of the remaining GitHub issue list is either big rocks, by which I just mean, some of them are ones that are complicated to solve, but some of them are just things that are big. But some of them are also issues where I felt like we really needed more working group discussion, and the correct answer wasn't just obvious. So what I want to do with the remaining of my 12 minutes and 29 seconds is I have, I think, 11 or something different issues on the following slides. That doesn't cover all of the issues. That covers the issues that I wanted your help with. Please feel free to hit me with a clue bat about other issues as well. So before I jump into that, just a quick thing at IETF 124, I projected this slide. Having now gone through one iteration, I propose to make this little change, which is instead of for every PR that I merge, that we do a mailing list confirmation before that. That just seemed too ponderous, and I didn't end up doing it. I did end up mailing the list about a few things, but not most. So I propose, in interest of not spamming the list and also in interest of getting things done, that we adopt this instead, which is just that, one issue corresponds to one PR, and that hopefully makes your review easier and hopefully makes unwinding anything that I did wrong easier. If anyone has any issues, not to pun, about this, you can either run to the mic or email the list or whatever. Okay, on to the issues. And I'm just taking these in numerical order. So, first one, graceful restart. RFC 4724 hacks the FSM a fair amount. I think that for all of our RFCs that hack the FSM, it is desirable, and assuming that we keep the FSM in the base spec, which I think we're going to, unless somebody wants to convince us not to, which would be awesome, but I think is probably not really the smart thing to do, though it might be the brave one. Anyway, I think that we should try to bring the base spec FSM into as much alignment with what we actually have running on our routers as we can. That means pulling the graceful restart FSM changes into the base spec. And it's difficult for me to see a way to do that cleanly without pulling all of graceful restart into the base spec, because otherwise you're kind of pointing back and forth between an already published RFC, which is over there, and a base spec, which is over there and is newer, and it just seems really weird. If anybody has any brilliant ideas about how to finesse that, cool. Please tell me. I'll be here all week. We don't necessarily have to do it at the mic, but right now I'm kind of thinking that even though I really don't want to, that for this and a number of other RFCs that touch the FISM, we maybe just need to pull them into the base. My assumption is, though, that for things like Graceful Restart, which not everybody implements, not everybody should want to implement necessarily. I don't insist that everybody have it in their implementation, that we make it clear in the base spec that it's an optional feature. We didn't so much have a concept of optional features in 4271, so we're going to need to invent some consistent way of doing that. And now we're going to have something that looks like a PIX pro forma to even figure out whether it, which bits of 4271 BIS you comply with, which makes me sad. I see Sue in the queue, and I think it's probably better if we just take questions live because each issue is a different issue. Sue? Unless you'd like to do it differently, but this makes sense to me.
In some sense, some of the parameters for FISM were already optional features. So
you think we have a pattern we can follow?
we have a pattern you can follow. The work done for the quick stuff is also probably got some informative. We'll hack on that in the GitHub when you could. But I think I know a way path forward, having done it. But I think Ying Zhang and the standard group of
Usual suspects?
sinners, yeah.
Okay. Thank you. Right. Next issue is extended message sizes. I like extended messages. I don't know how widely fielded they are. I do know that if you go and look at RFCs that normatively reference 8654, there's two BGPLS ones that say it's recommended that you should support extended messages if you're using BGPLS. And I see that BGPsec says something that's not quite as strong as that, but it pretty much says, please do extended messages, guys. So extended messages is written in such a way that we don't have to pull it in. We can leave it alone. I think that it would be responsible to at least include a pointer, in the part of the text that talks about max message size and say there is this extended messages thing. Or we could roll it into the base spec. I would be interested in the working group's sense of whether we should just make it part of the base spec or not. Again, put it in the chat, although the chat's kind of ephemeral. Talk to me later, send it to the mailing list, run to the mic, whatever, but please think about this question. I see another person in the queue. I see Sue in the queue. I don't know if you're in again or, okay, you're off.
That's me. I just have a quick comment. I love the fact that you're keeping things out. The doc has already reached 100 pages. I don't think anybody is going to implement BGP from scratch, but if they do, it's going to be super painful to read 100 pages and implement it. I'm sure there are geniuses out here.
Yeah, the question is whether it's more painful to read the 100 pages or whether it's more painful to read 105 page. Do I want to read 100 pages plus a whole bunch of other docs, or do I want to read 120 pages?
Yeah, but I think that's why keeping it out makes it good for time being, because as you increase, I don't know, I'm probably the answer to that lies in IDRP back in the days when you implemented it, so you'd probably know.
Yeah, I don't want to go back there.
So John, how much of that is FISM text?
Of extended message size?
No.
Oh, how many? Is that the
Size
page
of
count?
size of the VIS.
Oh, I'm not, something like half.
There might be our only other way to do this.
Yeah, right. We can talk about that later. I don't have that in this slide deck.
But it's good you're keeping things out.
Okay. Right. Ketan.
Ketan Taravlikar, as a working group participant, just wanted to clarify on this extended message for BGP LS, and that was really required because the BGP LS attribute has been becoming a larger and larger something that I will not say. And there was no way to do this without the extended messages. So that pointer was really required, but I just want to call out for all BGPLS implementers to be careful about it. But
Got it.
that's the thing. I'm not sure if it applies for BGP so much in the internet routing though.
Yeah, although I'm not sure what our key sizes are in BGP-SEC these days, but if we ever get BGP-SEC out in the field, it may be really important all of a sudden. I see that I've got 3 minutes and 35 seconds left, and I've covered like not very much of my slides. So what I'm going to do is, instead of trying to speak to all the slides, I'm just going to fly down them, give you, a quick overview of what's in here. People can look at the deck later. I'm going to be around all week. We can talk about it, find me, send me an email, something. Sorry. Yeah. TTL security. There was a suggestion made that we mandate TTL 255 as a default. A lot of implementations do TTL 1. It's not actually required in the spec as far as I was able to tell, although all the implementations I've worked on have done it. The words mandatory and discretionary were in my opinion a well-intentioned mistake, and I think we should get rid of them and just say what we mean. The legacy NLRI encoding. Okay, I do want to talk to this slide. There, 4271 talks about an encoding that only covers AFI-SAFI 1.1. I will tell you for certain we will not get this document progressed unless we cover IPv6. We can do it as a cluster with the BIS 4760 plus whatever the other one is for IPv6. We can do it by rolling all this stuff in. We maybe are not actually doing any favors to our readers if we continue just describing the legacy encoding in the base spec, even though it's the easiest thing to do. So I laid out 4 options. I crossed out the ones I think are not the best options. I'm okay with either saying, here's the document, it has the legacy encoding, but for God's sake, don't use it. Go look at 4760 instead, or we could roll in 4760 and just describe what we mean in terms of the encoding we prefer. One is less work, one is probably the right thing. Tiebreakers. Somebody opened an issue saying, please add shortest cluster list. Jeff added, by the way, we need to be able to talk about how we augment tiebreakers in the future. I think that sounds great. I don't know how to do it. Please send text or at least a clue. Remove private. It was proposed that we should document remove private AS, which pretty much everybody does. It's not in any spec that we've got as far as I know. I'm not sure what to do. Do we document one required mode? Somebody's going to win, somebody's going to lose. I guess we could pick a required mode that nobody implements there. That way nobody loses. Or nobody wins, rather, everybody loses. We could document the union of every single thing that exists. I'm not sure. Please send ideas. I added a registry for attribute flags. The big question here is, are attribute flags ever going to be useful? If there's any chance they're going to be useful, we should have a registry. If we just think that they're toxic waste, we should say they're toxic waste. This is a fairly involved 3-slide set. Maybe I'm the only one that it makes sense to. I'm not sure. The kind of bottom line is, it's in the slides. Please read them. Somebody review it. Better advice about the origin attribute. there's an issue saying, can we please say something clearer about how IGP versus incomplete gets used, because the RFC is not very clear and different vendors implement different things. Robert suggested in the email around that proposal that the should not in the quoted text should be changed to a must not. The should not is from the base spec. I think personally, I think this ship has sailed, but we need to have some working group consensus whether we try to prevent people from changing the origin in flight. I don't think we can, but again, it's open for discussion. Almost done. This came in last week from IANA. They said, do you guys want 0 and 255 and the ASPath seg types to be, some form of reserved or what? Yeah, so I'm out of time. Thank you to those who have contributed PRs and who have contributed issues and comments. All of you who haven't done it yet are welcome to do it. I will say that working in this mode, I was a little skeptical, but I was completely wrong. I feel like this is allowing me to be productive and collaborative with you guys in a way that wouldn't have worked very well just in an email workflow. I'm around all week. Please, let's work on this. Thank you.
Hey, one real quick comment. I'll catch up with you, but when this document becomes a standard, do we have to worry about interoperability?
Do we have to worry about interoperability?
40 to 71
with
documents. Should we change the language in a way that it changes the old text?
I do not. I think that in the when I was pitching this as a working group document, I think I said the goal is not to have normative changes. The goal is to document what exists. I think that's still the goal. If we want to make any normative changes, I think that's a really big deal, and the working group has to be very, very clear that that's what we're doing.
Perfect.
Okay. And feel free to keep going. There's 2 trailing comments. Trailing comment number 1, see the IEPG meeting earlier this week where they talked about the use of the origin attribute. People are absolutely using it in the field, and it makes some people very uncomfortable. And the next piece covers our next presentation. We do have a discussion about what we do about cost, installation, and everything else. So just as a prelude for the talk, we have had at least 3, and I think we're starting to find evidence of a 4th proposal from over the years covering how we actually do resolution, costs, and how this actually may differ on a forwarding basis. So, Olivier, I'm going to pass you slide control in a second.
Thank you. So, hello, I'm Olivier from Cisco. So, I will present you the update on the BGP best path next up selection draft. So, on behalf of the co-authors, so we have Kendall from Bell Canada, NG from Huawei, and Israel from AT&T, which have joined as co-author on this draft. So, let me just recap the problem statement. So RFC 4271 is considering that the next stop is actually used for forwarding. So meaning that reservability condition is based on next stop, and IBGP path daybreaker is based also on the next stop metric coming from RIB. So with the new data plane like SV6, MPLS, and all tunnels that exist, this assumption is not true anymore, which lead to 2 main issues, which is traffic drop or suboptimal routing. So most of the implementation already addressed those 2 issues. So the goal of the draft is really to standardize those behaviors. So for the traffic drop issue, so let's consider this topology of MPLS VPN. So we have 2 PE, PE1, PE2, which are advertising P/M prefixes to PE3. So if we are looking at PE3 routing table, so we have reachability to next stop 1, next stop 2 from PE1 and PE2. So the resolvability condition is okay based on the RFC 4271. But we don't have any valid MPLS LSP toward PE3 to PE1. So that will lead to a traffic drop because BGP will select the path to PE1 as the metric cost is lower than the path of PE2. So that's the first issue, the suboptimal issue. So same topology, but now we are at the intent of low delay matrix. So the green matrix of the low delay one. We materialize those low delay paths via SR policies. So now we have both the next stop reachability with their own matrix and also the SR policy with their delay matrix. So based on RFC 4271, the matrix that will be used for the path comparison will be the path from the next stop reachability and IGP. So we'll compare 2 versus 6. And the intent that we have here is to compare the delay matrix, which should be 12 versus 4. So here, based on the RFC, we will select a path toward P1, which is not the optimal path that we would like to do, which should be the path over P2. So with those metric considerations, so we have also now the consistency of the cost type when we do the comparison. So if we're taking the same topology as the previous example, but we just have here the SR policy, which is down to P1. In that case, we will do the comparison between the IGP metric versus the SR policy metric, which are a delay one. So it's different type of metric, and the comparison will not have many sense to do the comparison between IGP metric versus a delay metric. So by the way, here there's a mistake in the slide. It's not a cost 6, it's a cost of 4 that should be reported to BGP. So in the draft, we introduced the resolution preference for this. So operators will add some configuration to set the preference. So let's take the assumption that here we set the preference of 110 to LDP and the preference of 20 to SR policies. Then based on that preference, we will remove all the paths that have a higher preference than 20. So here only path 2 will be left as a candidate path. So we will select the path with the correct intent. So we also add a section to the draft about the relationship with BGP best path selection criteria. So that draft was mainly focused on the reachability checks, and it's MPLS centric, so it doesn't really fit with the other underlay architecture like SRv6 and tunnel encapsulation. It does not address how to accurately determine the internal cost, and also like a solution for the comparison and consistency cost types. So the example that we just showed before, IGP metric versus delay. So based on the feedback and the command that we receive on the mailing list, so we replaced the previous forwarding address and context model with a formalized path resolution tuple. So the key of that tuple will be the address of the forwarding. So it could be the next stop, the tunnel egress endpoint, or the SRv6 SID. And optionally, we can have also the context that will help for the resolution. So that could be something that define which table to look at, or any attribute that we can have in those tunnel encapsulation attribute, or the color extended community, or any specific field in the SRv6 sub and sub-sub TLV other than the SID, of course. So we also add a section about the routing loops and endpoint clarification. So that's mainly highlight that with the tunnel technology, the resolve endpoint is the egress of the tunnel, which let us know that the intermediate nodes will not have any BGP lookup in that case, so minimizing the risk of any routing loop. We also had some example of the intent-aware transport. So we had implementation example with BGP CT resolution schema and BGP car. So as next steps, we are preparing for the working group call adoption. We already received some interest from multiple operators on the mailing list. Based on the feedback that we receive from other vendors, we need to do some reworking on the resolution preference mechanism to be more generic, to better align with the existing implementation. And we also need to take other drafts as a consideration, like multi-next stop attributes. Thank you.
Thank you. And you have a question in the room, Zhen Chang.
Zhen Qianglei from China Mobile. Thank you very much for your presentation and your work. I think this work is very useful for for the operators' product networks, especially when they deploy segment routing policies like China Mobile. But this document has overlaps with one of my drafts. In this morning, I sent one mail in the working group mail list and also to the authors of this one. Please read it and check the authors of my draft. Appreciate your response. Thank you.
Okay.
Xiaohu?
Xiaohu from China Mobile Cloud. I have a question about the information on page 5 and 6. Okay, in this scenario, could we just use Anycast next hop, and then you establish direct BGP sessions between two egress P routers? In that case, maybe the issue could be solved without any new purchase.
I'm not sure to see how the Anycast will resolve the different matrix types.
Use Anycast endpoint as the SR policy. There are two egress P routers, P1,
Yeah.
P2.
P1
right?
and P2.
Those two P routers will be used as the endpoint of the two SR policies, right? One is IGP cost based, another is latency based, right?
Okay.
So if you prefer to use low latency SR policy at the transport layer, you just map the VPN service over the low latency SR policy, because both SR policies use the same endpoint, which is Anycast address.
I apologize, Xiaohu. So we're running shy of time. Would you please send the example to the mailing list so it can be discussed?
Okay, thank you.
And John, you have 15 seconds.
Your talk comes, John Scudder, your talk comes well right after mine. You may have noticed that I was also talking about the resolvability condition. We're probably not going to get around to standardizing your thing before we publish 4271 bis, I hope. Not because I want you to be slow, because I want to be fast. But it might be worth thinking about how we could modify 4271 bis to be pluggable so that you have like a cleaner way of inserting your thing once it's ready to insert. So maybe we should talk about that or think about that. Point being, please think about something that could change, if it changed in the base spec, would make it easier for you to spec what you need. You see what I mean?
Okay. Yeah, let's discuss.
So just a couple of procedural notes. So we are going to be starting the adoption for this pretty much after IETF. Part of the chair discussion is figure out exactly what adoption we're running. And as you've noted, we have more than one draft that has touched this over time. And as John is pointing out as well, we have 4271 BIS considerations. This also overlaps in strange ways versus the cost community, which has been out for a while and is incompletely supported across vendors. So this is a interesting problem, and the general thing that the chairs are looking at is that we have energy to actually do something right now. So the likely outcome is that the work itself is the thing that's put out for adoption, and the actual form of the draft and the author set will be part of the discussion a little bit later. So please look for that coming up after IETF, and we look forward to taking this work forward. So thank you for the presentation. Next one is going to be on source selective BGP.
Hello, everyone.
Close, please.
Hello, everyone. Can everybody hear me?
Raise the microphone. Raise it 5 centimeters.
Raise the mic or just hand hold it. There you go. Hello, everyone.
Shout.
Hello, everyone. I'm Camille Braat, and I'm going to talk about source selective BGP. There are two internet drafts that I wrote, and the first one is source selective BGP framework, and it's an informational draft that provides an overview of source selective BGP. It describes some use cases, and it also includes some considerations. And the second internet draft is about is a standards-based internet draft, and it describes the new proposed BGP attribute called source selective. So before I go into the solution, first I would like to discuss the problem statement. So in order to explain that, I have created this network diagram with on the left-hand side an hand side A, and that connects to the internet with an access link, a 1 gig access link to ISP-A, and ISP-A connects to ISP-B and then to the internet. And on the internet, there's an end side B that sends traffic to end side A, and all is running fine. There's no overload in the links, so the communication is fine. But then a DDoS attack is launched at end side A. And it's a 4 gig DDoS attack that causes an overload of the access link, and that causes the site A to become unreachable for end site B on the internet. So how do we solve this? Well, the first approach is end site A tries to filter out the DDoS.
My apologies. The remote side is having trouble hearing you. Try rotating the microphone slightly. Is it? Oh, you lost batteries. So
switched off. Batteries are run out.
you would have to shout a lot harder for them to hear you.
Okay. Can you hear me now? Yeah, that's very better, much better. Okay, great. So yeah, okay. Let's So Nsite A puts a firewall in place and then filters out the DDoS traffic, and that works very well for the internal IT systems of Nsite A. But still, the access link towards the internet is overloaded, so Nsite B on the internet can still not reach Nsite A. So in order to solve this, Nsite A has to contact its ISP-A provider. And if ISP-A puts a filter in there, then it can absorb the 4 gig DDoS attack and deliver the connectivity to Nsite A again from Nsite B on the internet. So all is fixed. But what if the attacker decides to increase the volume to 100 gig? Then ISP-A will have an overloaded uplink to ISP-B, and Nsite A is not reachable again. So the only solution here is that ISP-A contacts ISP-B and asks to mitigate the DDoS attack on behalf of Nsite A. Working for a tier 1, we experience on a weekly basis terabit level DDoS attacks, and we can successfully mitigate that because we have a massive uplink capacity of tens of terabits. Here's with that my problem statement. So terabit level volumetric DDoS attacks can only be absorbed by massive transit networks serving tens of millions of subscribers. So how can we use these large networks and their massive ads capacity to protect hundreds of thousands of individual customer services? And with that in mind, we also have to consider the engineering constraints. First of all, on the data plane. And these are large networks, they have existing routing hardware, and they are not going to do a massive ASIC upgrade all around the network. So it must work on existing routing hardware. Then on the control plane side. So in order to scale to hundred thousands of precise rules, we need to also be careful that we don't destabilize BGP or exhaust TCAM resources in line cards. And then we also need to think about divisibility, meaning the architectural openness and the standard routing visibility to facilitate cross-domain troubleshooting. And with that problem statement, here's the proposed solution. Source selective BGP. So what are the two main components for source selective BGP? First, there is a BGP attribute called source selective. And that attribute contains a list of references to RPKI objects. And this BGP attribute can be used in combination with the BGP unicast, IP version 4 and IP version 6. And the second main component is a new RPKI profile called source prefix authorization. And that's the type of RPKI object that is going to be referred to by the source selective BGP attribute. And this RPKI profile contains a protected prefix, which is a small IP version 6 or IP version 4 IP address block. And then along with that, there's a list of authorized source prefixes. And these authorized source prefixes, they are authorized to send traffic to the protected prefix as the destination. And this whole object is signed and published by the IP address holder of the IP addresses in the protected prefix. So how does source selective BGP get applied into the network? So in order to illustrate that, I have included here a network topology. It has networks 1 to 5, 1 to 4 have RPKI activated, and 5 is there as well, and then you have the rest of the internet. And inside network 1, there's a firewall, and that firewall has been assigned IP address 192.0.2.10. And it's assigned out of a /24 block that is assigned to network 1. And network 1 would like to make sure that all the traffic that is sent to the firewall is sourced from two prefixes, the two prefixes you see on this presentation. And this is applied as following using source selective BGP. So network 1 first creates an RPKI object of type source prefix authorization, and in that RPKI object there's a protected prefix that lists the firewall, and then you have a list of source prefixes with the two /24s. And once that is validated and published by network 1 and it's fully distributed, then network 1 can augment or adjust the BGP unicast IP version 4 advertisement for the /24 with a new path attribute being source selective. And that source selective path attribute then refers back to the RPKI object, and as this BGP information propagates across the network, source selective BGP supporting routers that are configured to implement source authorization policies for network 1 can activate this source authorization in the data plane. And one example of how that looks like is included under callout point 4. There you have a route table for router 4, and you can see there that there's a new entry for the firewall IP address. And that new entry points to an allow list, and that allow list includes the two /24s. And when a router hits that specific route entry, it will have to perform a second lookup, a longest prefix match lookup for the source IP address in the traffic that is being routed by the router. And if it hits it, it will allow the traffic. If it doesn't hit it, it will just drop the traffic. So that's how source selective BGP gets applied to the network. Just to be clear, source selective BGP is not a mechanism to achieve source address validation. Instead, it's building on top of source address validation. It requires source address validation, but it adds source authorization on top of it. Source selective BGP is also not going to change the way BGP does route selection. And it also is not mandating any packet filtering behaviors. The source authorization policies can be implemented, but it's not mandatory. And also the way it's implemented is also not specified. Then some feedback that was received on the mailing list based on the internet drafts. So the first one is path MTU discovery, because source selective BGP is filtering out packets. The MTU discovery needs to happen on the packetization layer end to end. And then it's very important to realize that source selective BGP is designed specifically for tier 1 networks, or for high capacity networks that have the ability to mitigate DDoS attacks at terabit level. And therefore, source selective BGP must be extremely scalable, and it must be able to serve hundreds of thousands of protected prefixes with potentially millions of source prefixes. And that must all be implementable in standard routing forwarding hardware. And then source selective BGP is leveraging standard BGP unicast update stability, also something that a large network would like to see. And then there's the dependency on source address validation. So yeah, in order to implement source authorization, you need to have source address validation applied for the authorized prefixes along the full forwarding path. Otherwise, you're just exposing an internet user. So therefore, my suggestion is to start with implementing source selective BGP only for IP prefixes in your own customer cone. And as multiple customer cones start adopting source selective BGP, you can also interconnect these customer cones, exchange prefix sets that have this stuff applied, and then deploy source selective BGP across multiple customer cones. And then there is the challenge with source selective BGP that internet users will have to send their allow list via RPKI publicly. And that can be considered a security concern on its own. But I believe that if an internet user wants to put a permanent allow list right on the internet, it must be done with open visibility, because you need to facilitate the cross-domain troubleshooting and route validation. So this presentation is just to trigger your interest, and I'm requesting feedback on this proposal. I'm going to look at the feedback, and my next step is basically to incorporate all the feedback into a new version of these internet drafts.
We are at time. Alexander, if you have a short question, please go ahead.
I will try to be short. Alexander Azimov. So I have an impression that you believe that layer 3 firewall can be a solution for volumetric DDoS attacks.
Yeah, source selective BGP can be considered as an extension. So you have the firewall, but it cannot protect its upstream. So it's another tool to make sure that
it still works on a layer 3.
Yeah, it's doing source address validation, yes.
And what you will do with volumetric attacks on layer 4? It's unfortunately, I think you should consider a SYN flood with spoofed address space.
Yeah, so indeed, source address, source IP spoofing is a problem, but the assumption is that source address validation is in place for the source prefixes that have source authorization. Without source address validation, don't use source selective BGP.
So we have to cut the mic at this point. I will leave you with 2 quick comments. The first one is some of the scaling considerations that you're looking for have actually gotten discussed as deployment considerations for SAV. I think you're going to find the level of dynamic behavior or asking will not interact well with the use cases SAV has actually analyzed. So this is good for discussion. The second one is a number of people are going to be uncomfortable with this feature, much like UPA, because this is allowing for selective blocking to be generally put into internet no scope. So you're going to find that there's going to be security considerations around that as well. All good considerations to talk about on the list.
Thank you.
Thank you for the time.
Okay, hello, prepare your favorite paint. We are going to bike shed. Because this is the bike shedding talk. Yeah, nice. So I can see bad that. Okay, let's cope with that. So almost every attribute in BGP has some structure, but there are communities which are like lists of whatever it went in. So it's sets of UN32, it's sets of triplets of UN32 if it's large community, and then it's extended community, which is like total mess and nobody knows what's there. And if somebody knows what's in all extended communities, please raise a hand now. Nice. I mean, neither. So if we want to put it into the YANG, we can do it systematically. We can send a structure, which looks horrible, but it's systematic, and you can parse it. You can parse it by machine. You cannot parse it by person, or you can send the raw data. You can parse it by machine. You cannot parse it by person. Which, well, it should work. It's an API, but the problem is that people sometimes want to read the API output by hand, by eye. So this doesn't work either. So there is a compromise. Let's send render. But the problem is, in the end, that this must be parsed whenever it's used by the machine. But it looks like the consensus around the BGP YANG is that this is a better idea than having to parse things whenever looking at it by humans. So whatever, let's go with this. So this draft is going to define the standard render of whatever attributes needed. Because well, hello, Bert. We are using a completely different display of extended communities than everybody else. So everybody is using something delimited by colons. Bert is using something in parentheses delimited by commas. Well, why not? Let's go to the columns. We don't have problem with that, but we have problem with finding out what actually should we separate by the columns, because everybody does it differently. And let's say make it not ambiguous, so that nobody has to guess whether RT colon 1 is AS4 or AS2. So we'd like to also require a standard render in future definitions, so that we don't have this kind of problem anymore. There are extended communities doing various things like defining 84 flags, and there are others which are just 0, and there is no consensus on how to show this. Actually, we have more attributes. We have communities, we have extended, we have IPv6 specific, we have large communities, and all of these deserve some kind of specification. And then we have AS path, which came in just because basically everybody wants to display it, and showing it in different way is kind of clumsy, but it can be omitted if people don't like it. So the state of the work is, I have outlined what I'd like to see in it. I walked over a bunch of ECs. I have read more RFCs than I have ever wanted to read, and that's not even half of what I would have to would have to read. So there is much more extended communities to just check how they actually look like inside, which is also quite hard, considering some RFCs don't even say what should be there specifically, or what should happen if the value is different than specified. I may need some co-author because this is a lot of work. So don't raise your hand, everybody. I don't expect more than one volunteer. It would be still even too much to expect one volunteer. My thoughts just shortly before this meeting, I came across that draft in Grow in young BGP communities, which actually defines a JSON structure in which one can publish how the EC or communities should be displayed, or how it's structured. So I am in contact with Martin Bels, and we are going to find out whether this can be connected, so that in the end the new drafts, new RFCs would have to contain a piece of JSON which would define this, and then could be loaded into existing implementations without having to change the code every time a new RFC comes out. So there is also another plan on my side that I want to create an open source library so that everybody can see and check, even for the new JSONs, whether this actually works the intended way. So these are the discussion points, whether this is actually a concept we want, or whether we want to keep the whatever, how people display it, and let it be. I'd like to ask whether it's a good idea to adopt this now, or wait whether it's done and then adopt, because I think it would be nice to at least express the intent that we actually want to do it by adoption. And how to actually do the bike shedding. How to gather people and say, well, we want rt.as for IT-as for IT whatever, RT whatever, how to display flags, how to display this and that. And I am happy to look at you when you are going to bike shed. I don't care. And in the end, the question is how to incorporate this with the actual Young model, because I don't like blocking the Young model. On the other hand, it's a little bit bad to have a Young model with one specification and then say it's gonna be else. It's gonna be something else. So that's it. I'd like to, as I said, request working group adoption.
Luke, you have the mic.
Hi, Luc Hendricks, NLNet Labs. Yes, this is worth our time. I guess this is one of the things that I can't believe we did not have yet, right? So thank you for this. I'll happily take this and see how well scores my implementation, so to speak.
I intended this to not score well at any implementation.
well, we can discuss the scores offline. Two things. You mentioned an open source library. Is the idea to also come up with like this minimal test case with all the dirty edge cases and for implementers to validate their stuff, or because that would be,
if this is possible, let's go for this. Yet I need contributors for this, because otherwise I'm gonna drown in it.
Yeah, that makes sense. Yeah, I shouldn't make promises, but let's talk. Maybe the most important thing, if you haven't done so already, the maintainer of BGP Dump is here this week. Colin, he has probably printed more attributes than is healthy for any human being. So make sure that you pick his brain on this as well.
Yeah, I will talk to you later, because I'm going to lose lose that person's name from my memory in 2 seconds.
We'll make it work.
Perfect.
Thank you.
So I'll throw my comments in. Comment number 1, this is worthy work. We should do this.
Okay.
Comment 2, Yang gives us some extra tools here. So this is not only one way. SNMP used to have something called a display hint, so that you could have the canonical format and how it can be formatted. The Yang module made the choice that we have for extended communities, which is the only big mess, to have a raw format, so you can have a machine parsable piece as well along with this. And my expectation, if I were to implement the BGP Yang module for my stack, we would have a Juniper display format along with the IETF ones. This is meant to be everybody can use the same thing, but as an example, Bird would like to use its other format. That's allowable. You just need to have a standard way to transport it. So this is very good. And my last comment is that part of the headache here is their use cases are forked a couple of different directions. The Yang module represents the regular expression because it's expected to be able to take something as a configuration as well. Designing it that direction is wrong. We should start with a template of how things go. Martin's format also covers mostly parsing of things, but there's absolutely overlapping work there for having a format as well. And as Sue has pointed out on the side here, we have a consideration of once we have our procedures for this, registering these things in IANA and also updating the Yang module, which is intended to be extended. We don't have to get it right perfectly now, is a good direction.
Yep. Okay.
Thank you. And I'm willing to help, just as long as I'm not the author. I just mentioned registry. Okay. Slides. Next one. Enhancements, ECMP. Share, please.
This is Tang Wanlin from New S3C. This draft is about the BGP enhancement for ECMP EBP scenario. So the background, common spine leaf architectures for data center or AI network or DCI Connect network is often used multiple EBP sessions for ECMP. FC 5004 defined a load persistence algorithm to prevent unnecessary best pass transition, and FC 5004 state that the algorithm should not be applied when both paths are from the parallel EBP sessions. Also, FC 14271 early state that if the AS path attribute for BGP routers contains an AS loop, the BGP routers should be excluded from decision. So the problem statement, the first problem in this topology, when best router can be changed across the parallel sessions, the same prefix is received by SPI over multiple parallel EBP sessions, and FC 5004 persistence is bypassed due to a different EBP peer addressed and the prefix receives orders. For example, if the prefix receive orders on the SPI is peer 3, peer 2, and peer 1. First, we receive this prefix from peer 3, and we select peer 3 for the best pass. Then we receive peer 2, and we select best pass as peer 2, and we have 2 ECMP paths. Then we receive the prefix from peer 1. We have 3 ECMP paths, but the best path is changed to peer 1. So the best path changes continuous as the prefix is received due to the lower list peer change, peer address changing. The second problem is reductant advertised to the same AS parallel EBP pairs. A prefix is learned from an EBP pairs is unnecessary to re-advertise to another parallel EBP pairs in the same AS. For example, if the spy receives prefix from EBP peer 1, peer 2, and peer 3, the best path is peer 1, and the prefix will be advertised to peer 2 and peer 3, and then peer 2 and peer 3 will include this prefix from root selection. The proposed solution to enhance two mechanisms. The first is to keep root precedence extension for parallel EBP sessions. We provide an option to extend RFC 5004 persistence logical across all parallel EBP sessions. The new rules, if a new root is equal to the current best path and both are from pairs in the same identified parallel EBP pairs, then we retain the current best path so it can prevent unnecessary best path selection. The second, suppression of reductant advertised to the same AS parallel pairs. If the first AS equal to the pairs AS number, then the prefix will not be advertised to the same AS. For example, in these pictures, the prefix will not be advertised. When we receive this prefix from peer 1, we will not advertise this prefix to peer 2 and peer 3. You can reduce the unnecessary root update in this parallel EBP topology. So we propose some changes for BP path selection modification. The new step will be added before the BP identify compared in path selection. This step informs the new persistence rules for parallel EBP pairs, locking the current best path when the conditions are met. The second, we add advertise filtering rules. A simple AS path check prevent sending a root back into the AS which it came from different parallel EBP sessions. Both features can be configured. Any question, comment? Welcome.
So I apologize, we're out of time, so we won't be able to take questions here, but we do encourage mailing this discussion. And we're going to need careful discussion about this because any changes to path selection, especially for something that is time-based, tends to cause a lot of bugs. So we'll have to be very careful about how this works.
Thanks.
Thank you for the presentation. We are to our final presentation of the day. Yuan? Nope. Yes. Go ahead and take the controller. You will have control now.
Hello, everyone. My name is Yuan from Zhongguancun Lab. Our draft is street model for BJP color extended community. What is our motivation and background? The BJP color extended community creates a certain 2-bit user-defined value And the color value is locally configured, and it is designed to express forwarding intent within a single administrative domain. And nowadays, technologies use color to influence forwarding across S boundaries, such as SR policy, BGP CAR, and BGP CPR. As for SR policy, the role of BGP color select candidate paths for steering, and BGP CAR, they define procedures for color-based routing, and BGP CPR, the role associates color with IPv6 prefix. On your a local policy value become an inter-domain forwarding input. Next slide, the code gap, lack of attribution. The routing protocol doesn't provide information to verify where a color was attached or altered. ESA has a legitimate origin. The color value is 100, and ASB transit color value and LT in transit. Now the color value is 200, and AS3 is the receiver. He maps the color value 200 to local policy. We found that no color origin information is carried and no bounding between color and ES path. The color value is implicitly trusted and received. This created a gap in cross-domain routing decisions. So, the three characterization can be concluded as follows. Because color is an ordinary path attribute, and any entity that originates or forward a route can manipulate it. We consider the following three actors. As for network operators, they can attach, change, or strip color, motivated to steer traffic onto economically advantageous paths or off complex paths. And hackers, they compromise routers or controllers to enter as a route operator. As for criminal nations, they can coerce operator or use wiretapping to divert traffic for extortion, monitoring, or concealment. And we introduced the classes of attacks on BGP color. The attacks of interest violate the integrity and authenticity of color value. As for color injection, this attach unauthorized color, and the consequence is that traffic steered onto an intended, bypassed, or constrained path. And color recurring, it can transit speaker modifies the color in transit. The consequence is that multiplied effect across downstream ESs acting on altered intent. As for color stripping, they will remove transit color and controller attacks. They will compromise management system, define color mapping. Our draft scope to and follows to prevent the scope from expanding. We have strictly limited scope in the draft. First, color integrity and authority, and the ability of receiving ES to attribute color to an authorized origin. And last, an authorized injection, recurring, and stripping of cross-domain color. And next, residual vulnerabilities. Why existing security practices are insufficient for cross-AS color? Bordering filter is intention with transitive use, and BGP-SAC protects the path, not the attribute. And then distinguishability from local policy. And AS stripping a color maliciously looks identical to an AS stripping is due to legitimate local configuration. And last, trusted multi-development. Even within a contract confederation, there is no technical means for a receiver to verify origin authorization. Future work. While this draft doesn't pose a solution, the threat analysis points to two potential directions for future work. One is building mechanism, building a color value to an authorized orange AS. This could be a signed object or extension to BGPsec covering extended communities, and another freshness mechanism such as age of information (AOI) is associate a validate interval sequence number and timestamp with a color value to make stale and replace color values detectable. Thank you. Any question?
Quickly, you may in the future want to consider also the community container as a way to bind it. That does not handle the security issues, which may be better done in the RPKI. Thank you.
Okay, thank you.
One final comment. So this work is, I think, new and early. You are covering good security considerations. Another place for you to work and coordinate is the GROW working group does have a operational security document that I've mentioned before. Part of that document is trying to update community scrubbing, which overlaps the problem you're trying to solve. I think the best solution for you is to continue working on the document, coordinate both with IDR and GROW. And as we figure out, is this an operational document or is this a protocol changes, we'll figure out where the work belongs.
Okay, thank you.
Thank you for the presentation. And this concludes the IDR session for today. Thank you, everyone, and we'll see you for our 2 sessions at the end on Friday. Thank you.